Hello everyone. So I'm back today with a new topic. I was discussing about NMR spectroscopy, how to analyze the NMR samples. If you want to check them, go to my playlist that is created how to analyze proton NMR. I'll continue videos on that, but today I decided to make a different topic, so I chose a very favorite chapter of mine of physical chemistry, that is thermodynamics. So today I will discuss the preliminary things of thermodynamics, mainly the introduction and the first law of thermodynamics. So let's get started. Let me share the screen. As if you do not know about the details of myself and my research area, you can quickly check on these links for my LinkedIn profile, my Google Scholar profile, and my ResearchGate profile. So let's get started. So as I mentioned that today I'll mainly do an introduction, a quick introduction on thermodynamics. So what is thermodynamics? This is a branch of physical chemistry which discusses the relationship between heat and other forms of energy. As the name suggests, the thermal energy, the heat. So any type of energy can be transformed into heat. So thermodynamics defines the relation between heat and other types of energy. So which are some different type of energy? I'll quickly tell you about them. So, kinetic energy, a energy possessed by a body by virtue of its motion. Whenever a body is moving, it will possess kinetic energy. So, next, potential energy, energy possessed by a body by virtue of its position in a forced field, like a charged particle in an electrical field, it will have potential energy. Next, thermal energy itself, energy possessed by a body by virtue of its temperature. And then chemical and nuclear energy, energy possessed by a body by virtue of its constitution, like nucleus, it will have nuclear energy. Any type of chemical compound, it will have chemical energy. And then energy possessed by a body by virtue of its mass. And electrical energy, energy produced by a generator. Mechanical energy and magnetic energy, energy produced due to the magnetic properties. So then surface energy, energy created due to disruption of intermolecular bonds during creation of a surface. So these are some different types of energy. There are more and more. So thermodynamics briefly describes the relationship between thermal energy and other types of energy. Okay, so thermodynamics consists of three laws. Uh, First law is about the conservation of energy. Second law states the condition of feasibility of a process, whether a process will occur or not, the feasibility. And third law provides the method of estimation for different thermodynamical properties. I will go into details of all of them one by one. And then the zeroth law, it introduces the concept of temperature. Why the name is so peculiar, zeroth law? Because um, this law was discovered after the first law, but it was the very basic thing. So we call it zeroth law. But because the first law was already there, so we cannot say it second law, but By convention, it should be before that, so it is called zeroth law. So these laws, they are derived from practical human experience, and these laws have no exception. That is why thermodynamics is known as exact science. So now some points about the thermodynamics basics. All these laws of thermodynamics, they all apply to a system at equilibrium. So time variable is totally absent in this chapter. Thermodynamics deals with the macroscopic properties like pressure, volume, temperature, mole number, etc. It doesn't consider the microscopic properties or the constituent particles of the system. And lastly, thermodynamics, it has a predicting value. It is a predictive science. It can predict whether a process is feasible or not if you give some conditions. Okay, so today I'll mainly discuss about the first law. So I'll try to describe the first law. So consider I would show you a picture, the generation of electricity from a turbine rotates and it generates electricity. So the mechanical energy produced by a turbine is converted into the electrical energy. So here the amount of electrical energy appeared plus any friction losses, that is exactly equal to the amount of mechanical energy appeared. Sorry, this would be disappeared because we are uh, when the turbine is rotating, it is producing some mechanical energy. So this mechanical energy is being converted into the electrical energy. So some mechanical energy, the exact amount of the mechanical energy which disappeared, it should be disappeared, I'm sorry for that, it is equal to the amount of electrical energy appeared plus any friction losses, because we lose some energy due to this friction. Okay, so this is broadly the first law. Now I will tell you what is the exact version of the first law. That is, uh, energy can neither be created nor be destroyed. It can only be transformed from one form to another. This is the definition of first law. So, whenever one typical form of energy disappears, exactly equivalent amount of another form must reappear. As I already discussed there, the mechanical energy produced by the turbine, that is being converted into the electrical energy, and the mechanical energy which is disappearing, it should be exactly equal to the electrical energy which is being generated, plus there will be some energy due to the friction losses which we are losing. So this is the first law of thermodynamics. It is about the conservation of energy. We say that energy is like immortal. It cannot be created, it cannot be destroyed. It can only be transformed from one form to another. Okay. So these statements rejects the possibility of constructing perpetual motion machine of the first kind. So what is that? It was supposed that we can construct a machine which can produce work for indefinite period of time without any supply of external energy. That is particularly impossible because our first law says this. Okay, that energy cannot be created or neither be destroyed. So if we do not supply any energy, we cannot get some produce some work. So what is the mathematical form of this? So let we if we supply q amount of heat to a system containing 1 mole of gas in a cylinder, the gas expands from volume V1 to V2 while temperature changes from T1 to T2 at constant pressure. and if we get some work that is W, it is always found that this Q is greater than W. So because some energy will be lost due to some frictional or whatever internal change, so we cannot exactly get Q equivalent to W. So that amount of energy, Q minus W, this goes to increase the internal energy of the system. So this is broadly the mathematical form of the first law of thermodynamics. Negative W equals du, or Q equals du plus W. So now I would like to derive the mathematical form of this first law. So let me share the whiteboard. So, so what I was talking about is, let's say this is a container and we are supplying Q heat to it. Sorry for the handwriting. So it has a temperature of T1 which is being converted to T2, and it had a volume V1 which is being converted to V2. Okay, so as we mentioned in that first law, that if we are applying Q amount of heat and we are getting W amount of work, it will be added to the internal energy of that system. The Q will be equals to the W plus du, where W is the work done on the system and du is the internal energy, because some amount of uh, Q, the heat that will be needed to raise the internal energy of that system. So this heat is equals to the work done on the system plus the internal energy change of the system. Okay. Now, if we restrict this work, W equals to only mechanical work. So mechanical work, then it is only the work done is only due to this volume change. Like it is only changing the volume from V1 to V2. In that case, we can write W equals to PdV if we restrict the work done to mechanical work only. So as du. Okay, now we know that internal energy is a function of temperature and volume. So if we differentiate it, then du equals to del u del t v dt. So I hope you all know about this partial differentiation. If you do not know, I'll briefly mention some mathematical points in my next video so that you can easily know this differentiation integration is the basic math concept which is used in this thermodynamics. So I am doing here the partial derivative. So if u is a function of t and v, then the du will be equal to del u del t v dt plus del u del v t v v. Okay, so uh, as I mentioned, q equals to w plus du, so I'm putting this over here. So q equals to uh, del u del t v dt plus I am taking this dv in within the bracket, so p plus del u del v t dv. Okay, so this is one form of the first law, and if you take this volume constant, if you take, if V is constant, in that case dV will be 0. So in that case Q will be del U del T V dt. Okay. So if volume is constant, so we can take Q by del T V equals to del U del T V dt. Okay. So uh, so I have only just taken this Q by del T, and I have done a partial differentiation at constant volume. So we can see this. Uh, I'm sorry, we will not, dt will not be here because I have already taken dt over there. So, mm, okay. So Q by del TV equals to del U del TV. So now what is this? Q by del TV, this is CV. This is CV. I'm sorry. So this is equals to CV. What is that? That is constant volume molar heat capacity. You all must have known about this CV. This is molar heat capacity at constant volume. As you can see from this is heat capacity Q by del T at constant volume. We call it CV. So we can write the first law as Q equal to CV dt. I'm only putting this over here. Okay. So I'm just putting this over here. So Q equals to CV dt plus P plus del U del V d dV. So this is the mathematical interlude for the first law. It has many more mathematical interlude for different type of process and different type of systems. I will discuss about them in details in my next series of video of thermodynamics. This is just the basic, very basic thing of the first law of thermodynamics. So this is the mathematical interlude for very basic mathematical interlude for the first law of thermodynamics. Now I can discuss the same mathematical interlude for different type of systems, different type of processes. I'll discuss them in my next videos. So let's quickly go back to my presentation. So I was discussing this. The first law of thermodynamics, the basic mathematical formulas, the basic mathematical forms. Now I'll quickly discuss about the limitation of thermodynamics first law. What is the limitation? So the first limitation is that only a limited types of energy can be completely converted into lifting of mass against gravity. So as I said in the first law, that any type of energy can be converted to heat energy, or like energy can neither be created nor be destroyed. It can only be transformed from one form to another. But this is not entirely true. Like if you consider energy that is produced due to lifting of any mass against the gravity, so only a limited type of energy can be completely converted into this type of energy. Like thermal energy of a steam boiler or chemical energy of a compound can only be partially converted into lifting of mass, but it cannot be completely converted. So this is one type of limitation for the first law. We have much more limitations. So first law cannot state the exact criterion and condition in which energy conversion occurs. Like first law can only say that energy will be converted from one form to the another, but it doesn't tell anything about the criterion and condition in which this conversion can occur. So let me discuss this mathematically so you can easily understand. So these are, let's take two metal bodies. They are connected to a conducting wire. It has a temperature, A has a temperature of TA and B has a temperature of TB. And so first law says that if q amount of heat is lost by A, then exactly q amount of heat is gained by B. But what it cannot answer is that whether the heat flow will occur or not, whether that is the feasibility for the process. And then it cannot also tell that if the heat flow occurs, then to which direction it would occur, like it will be from A to B or B to A, and then how long will the heat flow continue. So first law cannot answer all these questions: the feasibility, the direction, and the extent of the process. First law cannot answer them. So that is why scientists they discovered the second law, which can answer all of these questions. Okay, so I will discuss the second law in my next lecture. I will also discuss the different mathematical form for different process and systems of first law in my next lecture. So please keep enjoying my lectures. This is the introduction. I hope you have enjoyed all of this. And please like, share, and subscribe to my channel, because as if you are viewing my channel, you are commenting, this motivates me to make more videos to which is helpful for the students. That is my main goal for this channel. So please do like, share, and subscribe, and comment in the comment section. So I'll try my best to answer all of your queries. So, okay, bye for today.